Algebra 2, Chapter 8.2, Exercise 1 through 10. This section of the book has to do with complex numbers in polynomial functions. And I historically have stayed away from complex numbers. And the main reason is that there's not really a path in calculus for this. And since I have Algebra 2 honors, pre-calculus, and calculus, I automatically look at funneling toward calculus. But in this section, there's a wealth of things that I find interesting, and so we're going to go over these. I'm going to do, in this set, the odd number problems 1, 3, 5, 7, and 9. Okay, the first section here, find all zeros of p of x, including any multiplicities greater than 1. And so we have the first one, p of x equals 3x cubed minus 10x squared plus 10x minus 4. So we're going to use the rational roots theorem. And basically, rational roots theorem is that we're going to have plus or minus the factors of the constants. In this case is 4. And so we're going to have plus or minus 1, 2, and 4 over the factors of our leading coefficient, which is 3. So 1 and 3. And so just distilling from here, what we have is our potential rational roots are going to be plus or minus 1, plus or minus 2, plus or minus 4. And now for the fractions here, we're going to have plus or minus 1/3, plus or minus 2/3, and finally plus or minus 4/3. So 6 different possibilities here, and times 2, that would be 12 potential rational zeros. So we're going to test these zeros, and I like to start with these whole numbers, the integers, starting the lowest first to make arithmetic easier. So we're going to test, first of all, the zero of x equals 1. And this will go really quickly. So to do this, we put the zero we're evaluating outside of the synthetic division bracket, and the inside we put the coefficients of the polynomial expression here, the function 3, negative 10, 10, and negative 4. And then we bring down this 3. 1 times 3 is 3, negative 10 plus 3 is negative 7, 1 times negative 7 is negative 7, and then 10 minus 7 is 3, 1 times 3 is 3, so we get negative 1. So we have not a 0 because we have a remainder not 0, so that's not a 0, so we're going to put an x right here. Next we're going to test the zero of x equal to negative 1. So we go about the same type of synthetic division bracket, but in this case with a negative 1 on the outside. Then we have 3, negative 10, 10, and negative 4. Same process. 3, negative 3, negative 13. That's going to be 13, 23, and we're going to have negative 23. So our remainder here is going to be negative 27. This is not going to work either, so I'm going to put a big X there. Now we're going to test x equals to 2. I hope we catch one of these soon here. So we're going to bring 2 on the outside, and then 3, negative 10, 10, and negative 4. So we bring down this 3, so we get 3. And so we have 2 times 3 is 6. We have negative 4 here. 2 times negative 4 is going to be negative 8. And 10 minus 8 is going to be 2. And 2 times 2 is 4, so 0. So what we have is, that is a test that is going to work, and so our factor related to this is going to be x minus 2. And so we have found that 0, so that's That's one of the zeros. X equals 2, we will say. I'll just put over here to write x equals 2, and make no mistake, that's related to problem 1, even though it's in the space over here. Next we have 3x squared minus 4x plus 2 is equal to 0, and we can test different ways to do this. If we go ahead and put an x method here, we can put a is equal to 3, b is equal to negative 4, and c is equal to 2. So we're going to have AC on top, which is 6, and the bottom we have negative 4. So what we want to have is, we want to find two numbers which, when multiplied together, equals 6, but when added together are negative 4. And so if you look at that, your factors of 6, and one has to be positive and one negative. You can look at 2 and 3, 1 and 6. Well, 1 and 6 are not 4 apart, neither are 2 and 3, and so this is not going to work. So we're probably going to be looking at complex or imaginary numbers. And to do this, we're going to use the quadratic formula, which is going to be x equals negative b plus or minus the square root of b squared minus 4 AC, and that would be over 2a. And so for this we have b is negative 4, so we're going to have x is equal to negative 4, which is going to be 4, plus or minus, we're going to have the square root of b squared. Well, we have b is equal to negative 4, so that's going to be 16 minus 4, and a is going to be 6, and c is going to be 2. And so it's going to be all over 2a, and it's going to be 2 times, in this case we have 3 for a. And so x is going to be equal to 4 plus or minus 16 minus 4 times 6 times 2. That's going to be 4 times 6 is going to be 24 times 2 is 48. 16 minus 40 is 32. So plus or minus square root of negative 32. And that's going to be over 6. And yeah, we're talking about irrational numbers now, or at this point forward, or complex numbers. So basically, square root of negative 32, we can, and I'm going to go to the right here. So we're going to have 4 over 6. That's going to be, well, I'm just continue where x equals, we have 4, 6, and what we're going to have is a square root of, I'm going to break this all up, square root of 4 times 8 times negative 1. And the square root of negative 1 is defined as I, and we take out this 4, we're going to get 2. That's plus or minus. So for this, we're going to get four plus or minus. We take that 4 outside, we're going to get 2, and then we're going to get square root of 8 and then I. And we're going to have this all over 6. And that square root of 8 can be broken down to square root of 2 times 4. So that 4 can go outside. So just bringing this down here, run out of 4 plus or minus. We're going to have 2 times 2, so 4, square root of 2, I, and we're divided by 6. And so that's going to simplify to this 4 over, this is going to be 2. We divide 4 by 6, that's going to simplify 2/3. So we're going to have 2 plus or minus 2 square root of 2 I, and that's going to be all over 3. And so that's going to be, it's going to be our complex zeros in the lower right corner. Here, just raise it up, take a little bit better look at it here. And then we have our real zero here, x equals 2. Okay, so that's that one. So next we go to problem 3. Okay, solve the polynomial equation finding all roots. And for this, this is one where it's kind of advanced factoring is warranted here, but it may not be readily visible. But this one here can be factored by using factoring by grouping. And the way you can tell is proportionality of these two groups. You see that the ratio of 2 to 3 is the same as the ratio from 8 to 12. And so we're going to factor out this first group, and the greatest common factor between, I'm just going to rewrite this, so we have 2x cubed minus 3x squared, and our greatest common factor between those two is going to be x squared. So x squared times what equals 2x cubed? Well, that's going to be 2x. And then x squared times what equals 3x squared? It's going to be minus 3. And then we're going to add this here, and we have this next group, which is going to be this 8x minus 12. What is our greatest common factor here? Well, our greatest common factor here is going to be, looks like 4. Yeah, 4, right? So we have 4 times 2x minus 3. What do you know? So we have here is, we're going to have 2x minus 3 times quantity x squared plus 4. And so if we set, and again these are all going to be equal to 0. So if we use the zero factor property or zero product property, we're going to have 2x minus 3 is equal to 0. So if we add 3, so we get 2x is equal to 3, and divide by 2, we have x equals 3 over 2, and that's going to be a real 0. And the next, we can take this x squared plus 4. Now, x squared plus 4 is not factorable. When you have x squared plus something, that's not factorable. But if we set this equal to 0 and we subtract out 4, we're going to have x squared equals negative 4. And if we take the square root of both sides, we're going to have x is equal to plus or minus square root of negative 4. Now the square root of negative 4 is equal to the square root of negative 1 times the square root of 4. And the square root of negative 1 is defined as the irrational number I. The complex number I. So what we're going to have here is x is going to be equal to plus or minus 2I, because that square root of 4 is 2. So here we have our complex zeros and our real zero, and that's that. Okay, in this set here, write the polynomial function with the least degree and a leading coefficient of 1 that has the given zeros. So, and what we're going to do is, it doesn't say this, but we're going to put this in standard form. And we're going to go from factored form to standard form. And what we're going to have, if we have this 0 of x equals square root of 5, and because that we have a irrational number as a root, they come in pairs, so x is going to have to also be equal to negative square root of 5. And so now we can set this up as our function is going to be, I'm just going to call this like f of x, kind of a standard generic function name, is going to be equal to, if we have x equals 0, that's going to be one of them. If we have x equals 2, our factor for that, if we subtract 2, is going to be x minus 2 is equal to 0. And so, let me just make a little more room to come across to the right. So we bring down here f of x is going to be equal to x times quantity x minus 2. And then our zeros here are going to be x equals square root of 5, x equals negative square root of 5. So we're going to have x minus square root of 5 times quantity x plus square root of 5. And then we can multiply all these together. Well, if we multiply this x minus square root of 5 times quantity x plus square root of 5, we're going to get, we'll just do this one at a time, so I'm just going to work to the right. I'm going to bring over this x, quantity x minus 2, and then we're going to have, this is going to be x squared minus 5. That's multiplying these two last factors together. And next we can use different methods to put all these together. We can take a box method and take our x squared minus 5 and multiply that by x minus 2, and we work that out. We get x cubed. We're going to get minus 5x here. We're going to get minus 2x squared here, and finally 10. So we're going to take x times, we have x cubed minus 2x squared minus 5x and plus 10. And just multiplying all these together here, distributing that x to everything inside parentheses, we're going to have x to the 4th power minus 2x cubed minus 5x squared plus 10x. So that's going to be this function written in a standard form. Okay, so that's going to be our answer here for this one. And let's see here. Next, we're going to go to problem 7. In problem 7 here we have this 1, negative 1, and with that multiplicity of 3. So what we're going to have is x, if x is equal to negative 1, and we solve that for 0, and we add 1, we're going to have x plus 1 is equal to 0. So that's going to be one of our zeros, and that one with the multiplicity of 3. And then we're going to have x is equal to 1. So we subtract 1. So we're going to have x minus 1 equals 0. So that's a multiplicity of 1. And then for the 3i, well, because of the same thing I mentioned earlier, we're going to have x is equal to 3i, and x is equal to negative 3i. Because whenever we have a complex, a non-real root, they come in pairs also, just like that square root. So what we're going to have is, I'm going to say f of x is equal to this with the multiplicity of 1. So this right here is going to be multiplicity equals 1. This is going to be multiplicity equal 3. So we're going to have this this quantity x minus 1, and we're going to have this quantity x plus 1 cubed, and then we're going to have this 3i business here, so we're going to have x minus 3i times quantity x plus 3i. And so that's what that one's going to be. So we got, if we multiply all this together, gosh, we're going to get a very high degree polynomial out of this one. And let's see what we get here. Yeah, it's going to be x to the 6th power. Okay, well, it's just a matter of cranking this out. So this last one here, when we multiply this together, when we multiply 3i times negative 3i, what we're going to get negative 9, and we're going to get square root of negative 1 squared. So what we're going to get is negative 9 times negative 1, which is 9. So what we're going to get here is multiplying these together here. I'm just going to cut it out here. We have x minus 3i times quantity x plus 3i. We're going to get out of this x squared plus 9. So we're going to replace this last one with x squared plus 9. So I'm going to bring down here this quantity x minus 1. Okay, and then this x plus 1 cubed. And then we're going to have this x squared plus 9. And so really for now it's just a matter of multiplying all these out, and we'll just do that x plus 1 cubed. So this is a binomial expansion, which is the pattern of 1, 3, 3, 1. So it's going to be, I don't expect my Algebra 2 students to have gone into the more advanced techniques of binomial expansion. So we're going to take this x plus 1 here, x plus 1, so x squared, x 1. So we're going to get here is x squared, plus 2x plus 1. We're going to multiply this by x plus 1, so we get x cubed, and we get 2x squared and x, and down here we're going to get x squared, and we're going to get 1 times 2x, we're going to get 2x here, and then 1. So we're going to get here is x minus 1 times, we're going to have x squared plus 3x, no, x cubed, excuse me, x cubed, we're get x cubed plus 3x squared plus 3x plus 1. Remember I was telling you about 1, 3, 3, 1? And then we're going to have this x squared plus 9. Okay, so now we're going to have this, I'm going to multiply these last two together, which is going to be a 4 by 2, so like this. So here we have this. So we have room for a 4 by 2. So we're going to put here 3x squared, no x, excuse me, x cubed, 3x squared, 3x, and 1 on the side here. We're going to put x squared plus 9. So we're going to get here x to the 5th power, and we're going to get 3x to the 4th power. It's supposed to be 3. And we're going to get here 3x cubed, and then x squared here. Then lower left we're going to have 9x cubed, and then we're going to have 27x squared. We are going to have 27x. And finally we're going to have 9. And then if we add all these together, we're going to get 20x minus 1. And then we're going to have over here x to the 5th power. That's x to the 5th power. And we're going to have plus 3x to the 4th power. We're going to have the x cubed. We're going to have 9x cubed plus 3x cubed, so that's going to be plus 12x cubed. And then the x's, let's see, the squareds, looks like we got 27x squared plus x squared. So that looks like it's going to be simply your 28x squared. And then we're going to have plus 27x plus 9. And so we have 1, 2, 3, 4, 5, 6. So we have a 6 by 2. So I'm just going to come down here, continue to go down here to the lower right. So we have these. So we're going to have x to the 5th power. Is there a better way to do this? Well, for me, I want to stay organized. So this is my preferred way of doing this. We're going to have 28x squared. We're going to have 27x, then 9. Then we're going to have over here on the left x minus 1. So we have x to the 6th power. We're going to have 3x to the 5th power. We're going to have 12x to the 4th power. We're going to have 20. That's going to be 28. That's an 8. 28x cubed. And we're going to have 27x squared. And we're going to have here 9x. And then here with this negative 1, we're going to have negative x to the 5th. So it's basically putting negative signs on everything that's on top here. We have minus 3 x to the 4th power, minus 12 x cubed. We're going to have minus 28x squared minus 27x, and then we're going to have finally negative 1. And so we're going to have f of x, just kind of assembling everything in one place. In one function, we're going to have x to the 6th power. And then we're going to have how much to the 5th power we have, plus we're going to have 3x to the 5th minus x to the 5th, so that's going to be plus 4x to the 5th power. And we're going to have, that should be 2x to the 5th power somehow. That's going to be, yeah, 2. Let's be 2x to the 5th power. Excuse me. And then for the 4th power, we're going to have 12 minus 3, so that's going to be 9 plus 9x to the 4th power. And then to the 3rd power, we're going to have plus 16. How do we get 16? 28 minus 12. So plus 16 x cubed, yes. Okay, the next one we're going to have is minus x squared, because we have 27 minus 28, so minus x squared. And then we're going to have over here 9 minus 27, which is going to be minus 18x. And finally we have minus 9. Yeah, it's going to be minus 9 right there. So yeah, a lot of assemblage work together to get this, but that's going to be it. Quite a bit of work there. The next one we're going to have is this one right here, forestry height and trunk volume measurements from 10 giant sequoias between the height of 220 and 275 feet in California. Give the following model where h is the height in feet and v is the volume in cubic feet. And you have this function here for volume in cubic feet based on height. And then we have this one here where we're given the president tree, which I happen to find out was named originally after President Warren Harding in 1923. Has a volume of about 45,100 cubic feet, and use a graphing calculator. So we're going to go to a graphing calculator here, and then we're going to find out, based on this, what we estimate the x-coordinate and see what that represents. So let's go over here, and we're given a suggested window here, which is going to be x minimum of 220 feet and x maximum of 275 feet. I'm going to have that scaled by 5 feet piece increments. And then for the potential y values, we have 30,000 as the y minimum and 55,000 as the y maximum. And I'm going to scale that at 1,000 foot increments. And then over here, we're going to put our function, which is going to be, now it's going to be 0.131. It's h, but we're going to put x to the power of 3. Over here, we're going to put minus 90.9 h squared. Make that x squared plus 21.2 x, and we're going to have minus, we're going to have, it's going to be like a 1,620,000 7,400. And then we graph, and this is what it looks like. I hope it shows up there. I don't see it showing up. Okay, 0.131. X cubed minus 90.9. Yeah, what it is, it's 21,200 x, so that's going to be 21,200. So this is going to help us out here. Let's try that. 21,200 x, and now we're going to have minus 160. 400. Okay, I think it's right now. Let's check it out. Okay, yeah, it looks better. So we see what that shape of that curve is, and we're going to put this second graph here of 45,100. We graph that. We see an intersection point here. We find the intersection point, second trace 5, enter. So we get a height of, looks like projected height of 265.1 feet. About, we'll say to the nearest foot. So x 265.1 feet. And what does that represent? So it represents that based on the volume, so based on V of H equals 45,100 cubic feet. Your height is estimated at about 265 feet. And I actually did a little research on this particular tree, and the real height of this is going to be, actual height is about 247 feet. So that's really a fairly good estimate. Anyway, that's all these odd numbered exercises. I thought it was a pretty interesting set, has quite a variety of things in it. I hope this has been helpful to you. Good luck, and thanks for viewing.